I'm Sam Curren. I'm here to talk about identity. I'm not even remotely an expert in the metaverse or in 3D modeling or any of that, but I do know about identity, and so that's what I'm going to talk about today. I work for a company called Indicio. We either help people with identity solutions or we help identity solutions with people, depending on your perspective. But we do a lot of stuff that is in the realm of digital identity. In the talk notes, we talked about information sharing and about how to share things, right? And we're going to talk about that, but we have to talk about identity first because of how key it is to what's going on. These are the legacy identity systems that we have today. Sites declare, they organize their own identity system because the internet was created without one. So they end up centralized, and together we got usernames and passwords all over the place. We're all very familiar with this unfortunate situation. We then have federation, which kind of helps, but also just kind of makes the problem a little bit wider and a little bit broader, and is also not an ideal circumstance. Decentralized identity works like this. Rather than having the site be the center of all the interactions, the user is the center of all the interactions. And data can be passed around between them through the user rather than instead of the user or around the back of the user as it goes. And so I'm going to talk about how this actually happens in some of the technologies behind here, but I wanted to start with kind of the vision of where we're going here, is that rather than us being subject to the identity systems of all of the different parties that we interact with, then we can have an identity and we can have data that sort of transfers through that whole system. There's going to be other folks that talk about other aspects of this as well with wallets and credentials and things, but this will be my intro. I'm not going to go super deep because of the time, but I would be happy to talk about any of these aspects. I'm glossing over a lot of technical details and even some controversy in the development of these things. So come to the session tomorrow and I'd be happy to answer any questions, or if you catch me out in the hallway anywhere. There's three technologies that are really powerful that combine together for decentralized identity. One is decentralized identifiers. I should clarify at this point that when I talk about identity, I'm not talking about identity in the social side of things. I'm talking very specifically about identifiers and the stuff associated with that. Verifiable credentials, and then communication and exchange protocols. And these are the three magic pieces that make all of the identity stuff work. My experience has been with deployments with mobile devices and with web technologies, but all of the same problems that we've had there are going to affect the metaverse in probably even more profound ways because of all the reasons that Royal talked about. And so this stuff translates really, really well into, so if I say site, you can translate that in your head to metaverse world or any of that, and it's going to apply the same way. So this is a DID, a decentralized identifier. And there's three parts to it. It's a URI, so you've got the URI prefix of DID in the beginning. Example here is the DID method, and then there's an identifier, a method-specific identifier on this side. You'll notice that this doesn't look like something you want to explain to your mother, right? And this is something like an IP address that should be hidden, but it's very powerful for what it enables. But this is a key foundational piece. When I go to Facebook or any company or Google or anything, they give me identifiers, and that often comes in the form of an email address. Email addresses are useful, by the way, because you can prove that you own them and you can communicate through them. And so we replicate those things, or we can replace them with some of these technologies. But the key bit here is that this is a foundational piece. So with each DID, and a person is going to likely have one or more of these. They could have lots of these. We're not going to have to interact with them directly. Our software will help us with that. So when you take a DID and you resolve it, then you end up with what's called a DID document. And the key thing to know is that DID documents contain public keys, and they contain endpoints that can be used for communication. That's what those contain. So if I give you a DID or you find a DID from me, then you'll be able to resolve it, discover a public key or more, one or more public keys, and how you communicate with me. And that's important, particularly when you don't have the same sort of interactions that we have where I'm in a browser or something else. If I'm in a metaverse world and I have a way to pass you a DID, then you could actually resolve that, connect, and begin transacting with an agent on my behalf to ask for information or to retrieve it. And that can be done in a way that's very immersive without having to pop out necessarily to like a web level technology to make that happen. So the important part about DIDs, by the way, is that it's an identifier that the user controls that can't really be taken away. Google, I have a Gmail address, for example. I'm Telegram Sam on all the socials, and I happen to be Telegram Sam at gmail.com. But Google, if they decided to take that away, can revoke my email address. It doesn't happen a lot, but it's possible. And now I don't have that identifier to use anymore. So any of my online identities that are linked to that are now unavailable to me. And DIDs are designed to be not removable without me being involved. I can burn one, I can make it unusable and throw it away, but that's a choice that I make and it can't really be done to me. And that's an important foundational piece. So let's talk about verifiable credentials here. Here's an example, driver's licenses. And this is the most common piece of identity that we use day to day. I had to present it on the way in so they could verify that I would match my vaccination record, et cetera, right? And so we all have these. These are really useful. This is issued by the government. They're the issuer, the authority about this data. And then they give it to me. And when I present it to somebody else, they can look at it. And there's a couple of things that will indicate to them that that's a valid, legitimate, non-faked or unmodified driver's license. There's overprinting. There's like the faded picture in the background. Things that are semi-hard to do, at least, if you're trying to fake one of these. And so they can physically look at that and understand that, like, hey, this looks like it was legitimately issued by the state that you're claiming to be, and then they can trust the information that's on it. So this is an example of credentials, passports, of course, or employee ID badges. There's literally tons of credentials that we'd interact with that we interact with already that could be in a verifiable credential form. The idea with verifiable credentials in the electronic sense is that we have the ability to see and read and understand the data, but also verify that it's authentic when it left the issuer. And so in a way, the physical driver's license card that we have is a little bit about portable trust. And this is really useful. When I handed my ID card out there, they didn't have to call the state of Idaho to make sure that it was actually me. They used the physical features of the card to gain some trust about that data, and then they were able to gain a good enough confidence that I matched the name, and it was the name that was on the other thing, and it was the name on the registration for the conference. That was portable because they didn't have to call Idaho to ask if that was actually true. Digital credentials need the same thing. You need the ability to present a credential and be able to validate or know if you can trust that without having to call the person that actually issued it. There's a bunch of privacy problems. I don't really want the state of Idaho to know every time I present my driver's license because that's a privacy problem. I don't really want them to know all the times, and I don't really want someone else to see the honeypot of information they know and go after that either. And so digital credentials need to do the same thing. And that's even more important. One of the cool features, okay, I'm skipping a slide here. There's a bunch of credential technologies that exist. And there's trade-offs to different ones. We're not going to go into those today because I don't have time. But there are efforts to standardize and figure this stuff out, and here's the names of some of them. One of the really useful things that you can do with digital credentials is that you can, one of the technologies that I picked, we're in Texas, right? So I picked a Texas driver's license as an example here. I think you can probably get a sample driver's license in every state. One of the cool things you can do with a digital credential that some of the credential technologies offer is called selective disclosure, is that you can reveal only some of the information that's actually in the credential without revealing all of it. And that's really useful. If I show someone my card, most of us humans don't have a photographic memory, which means they're going to look at it, verify the piece of information they want, and then they're not going to remember the rest of it. And that's a useful human feature for privacy reasons. Computers are not like that. They have to see all of the data in order to look at the piece they actually care about, and then they have to actively kind of throw it away or make sure the information vanishes, right? And that's a problem. It would be better for privacy reasons if I could not share the information I didn't need to share with them so that they have less of a liability in managing that data and everything else. And so you'll notice that I've cleverly blacked out some stuff here. If you only need to know the person's name and the state that they actually live in, that's what you can share, and you can avoid sharing all of the other information. And that's a really useful feature that I think is very helpful as we try to build systems where you're actually sharing information in a portable way, portable trust, between different metaverse worlds and platforms to make this happen. And so I wanted to bring that up specifically because it's a really useful feature that can limit sort of the data liability, and it can limit the problems that can result from the unfortunate misuse of digital identity. So, identifiers, I'm going to review the points I hope you remember. Identifiers that can't be taken away from people and are not unique to the systems you use them on. The second one is portable trust. Credentials enable portable trust. Communication and exchange protocols are important. This is a diagram that we often call a trust triangle. There's the issuer of a credential, and that's where the source of the information, so in the driver's license case, that would be my home state of Idaho. There's the verifier of information, and that's the lady at the desk out here that actually looked at my driver's license. And then there's the holder, that's me. The holder and the subject, there's some nuance there. In this case, since I hold it and I am the subject, it's the same. And we made this work. There are protocols for making this happen. To get a driver's license, so this issue credential side over here, I had to go to the DMV or the sheriff's office or however it works in your state, present them the right information so they know that it's me, and then they can take a picture and then they can mail me one, right? And that's how the physical credential got issued. And the process of presenting the credential is relatively easy. I just took it out of my wallet and then I handed it to the lady at the desk. When you do this in a digital way, you have to be able to communicate using standardized protocols so that both the software on both sides understands how to exchange the information. And that's the third really important piece. You need an identifier to base them on, you need the portable trust, and then you need to actually be able to communicate these things around to different people to make that happen. And so that's the third important piece. There's a variety of protocols that have different attributes and work in different ways. There's one that's based on OpenID. Chappy is a browser-based API for doing this, and one that I work with a lot is DIDCOM, which has both the up and the down of not working directly with browsers exactly, which means that it might work really well in the case that you don't have a browser, and if you're immersed in a metaverse experience and you have a protocol that can communicate with you, that's a really useful thing for the exchange of credentials and other information. So this whole picture is important because it allows for a bunch of really useful things. There's some privacy by design features in here. There's some zero trust aspects to this, and this is not theoretical. This is being used in real life to make this happen and to provide real value. It's early. It's at the very, very beginning of what we think it is, but it is something that is working and making it. By the way, I apologize for the slides not being according to the theme. That didn't happen. I was kind of a late ad, and you're glad I gave it to my slide guy because otherwise it would look way worse than this. So the fact that it's Indicio branded was not intended. That's just what my slide guy does. So I'm grateful for him making it look better. So here's an example of of a real world use case that we've done. There's more than this, but this is the one that I can talk more directly to. We did a pilot with CETA. CETA is a organization that works in the travel space that you have used and that knows about you, but you're probably not aware of. And the island of Aruba and the New York Health Data Exchange. And prior to the pandemic, CETA was trying to work on the problem of making airport lines go away, but in a privacy-respecting manner. It's easy to make the lines go away if the government knows absolutely everything about you, but that's not great from a privacy perspective. And so the CETA is trying to provide a mechanism to make that happen, but in a way that's a little better for privacy. And the island of Aruba really cares about tourism. And so they got this project barely started, and then COVID hit, and they said, hey, can we use this to solve COVID problems? And that's when we got involved. And so the idea is that you have a health information exchange that contains vaccination and or test data, like COVID test data, and then you have the island of Aruba that would really like to know that information when a traveler arrives. And then you have the traveler, of course, is usually the subject of that particular data, so you'll notice the form is similar to our previous diagram. The cool part about the portable trust aspect here is that the person acts as sneaker net between the source of the data and the destination of the data. In this particular case, there's a lot of health information exchanges or a lot of testing labs, for example, that exist in the United States. And that's just within the United States, not let alone the entire rest of the world. So if you were going to do this without verifiable credentials, Aruba needs to trust that data, which means that they would have to come up with some sort of database integration or API integration with all of the sources of the data so that when the data was presented to them, they could actually verify that it was in fact legitimate data and not something that somebody faked. And that's hard because there's a lot of those just in the United States and all over the place. Rather than try to come up with a way to make that happen, or maybe a centralized sort of clearinghouse where Aruba could call in and then they would call all the appropriate places. These are sort of anti-patterns for what we hope to do. Instead, we defined a standard for the types of credentials and the way that the governance would work inside the system. And then the traveler could be issued a credential of their test results or their vaccination record. And then they could present it to the island of Aruba in advance of travel and when they arrive to verify it again. There's a secret in the airline industry that may make some things make sense. If an airline delivers a passenger that's not allowed to enter a country, and the airline knew of that in advance, they have to pay to ship you back out of the country immediately. And so they don't really want to do that because it's an extra cost. And so there's lots of sort of arrangement to make sure that whenever you're going to some place that may not let you go there, that you're actually allowed to before you get on the plane. That's why, for example, they want your passport number, because they're often working through big centralized exchanges in order to clear your entry into the country using your passport number. And so the sharing in advance is a useful thing, and then when you also arrive, then you can present that information. And so to translate this into, like, great, this is nice, it's an island, we all like sand. In a metaverse situation, what's really going on here? One of the applications that verifiable credentials and all this digital identity stuff that I've been talking about can have in a metaverse situation is reputation. If you have built reputation on one platform in one metaverse world, it would be really nice if particularly new metaverse worlds could leverage that reputation to facilitate healthy interaction within a world. I don't know what the language for this is in the community, but the point, what's that? Oh, no, I thought someone had a better word than I had. So that way you can, if you show up in a new world, they can know a little bit about your own trust, and they can know, like, oh, this is a person that has a really good reputation in another place. Maybe we don't need to initially monitor or screen their interactions quite as well as we do someone that enters that we have no information about. And so that portability of reputation between worlds is an example of this, where doing the direct database integrations between all of the metaverse technologies that you might have might be really, really difficult and painful. But if you have a standard and you have a way to verify portable, trusted information, then you can allow the user to sneakernet that information between one metaverse world and the other metaverse world by issuing them a credential that they can then present on the other side. And so that's how this maps in a really cool way. The original goal of this was not actually to reduce direct database integrations or API integrations, but it turned out to be a crazy positive side effect about what actually happened. And so this was a pilot that we actually ran. The island of Aruba is still now, it's kind of post-COVID, and a little bit of the same fervor has gone away. And so they're going back to now and shifting back to the original mission of making sort of the regular airport lines faster. And so a lot of the stuff that we learned here is happening, but it's being applied in different ways because there's not such a hyper focus on COVID. This is pretty darn important to Aruba, as they are nearly entirely dependent on travel for the money that they make. So we talked about reputation. There's other things that are really useful here. Digital assets are useful. I should pause here to talk a little bit about the difference between a verifiable credential as information that is issued to me and something that's written to a blockchain. Blockchain data is really useful because it can be verified by everyone, but it's also really useful because it can be verified by everyone, which means that if you have information that is on a blockchain, this may not be information that you really want anyone to be able to read. And so instead of placing it on a blockchain to make that trusted, issuing it to the person in a way that's signed the way the verifiable credentials are, allow you to verify the information on the other side, but it's not really revealed until the subject or the holder of the data actually presents it on the other side. You can't just go mine that information off of the blockchain. And so they're related, but there's an important privacy difference that I, as a user, decide when I'm going to disclose that information. I really like that model because it models what we do today. Until I pull out my wallet and I start showing you the cards that I have in it, you don't know all the stuff that's in my wallet. And that's a really useful feature. And so though people are going to be using apps, not physical things in their wallets to do this, the model matches really well what our expectations are. I can pull it out and I can actively press the things on the screen to share that information, and hopefully the user experience is designed to make that really clear what's going on. Or I could be in a metaverse world and I might pull up my wallet and to be able to go through and select what I want to present and pass that to you, right? I'm assuming that lots of us in the metaverse world may have read Snow Crash by Neil Stephenson, right? This is like the seminal early work on this topic. They have the concept of passing a card that then represents something elsewhere. It could be a file transfer, it could be an identifier or something else. That's a way that I see this happening. I don't want that did to be obvious, but maybe the did is what's in the actual metadata when I pass that card in the virtual world. They can actually contain that. Similarly, credentials could have a card-like format where I can pick a card, indicate the information that I want to share, and then hand that then causes the protocols on the back end to actually go through the process of exchanging or presenting that information. So payment facilitation is a huge one. If you can onboard someone simply by knowing their DID, and you might ask them over a protocol and say, hey, how can you pay me? And they already have existing configured payment methods, then that's a huge, fast thing that you can do to facilitate payment. Now you know that you can charge things to them in that world without having to go through yet another setup process that everyone hates going through. Digital assets. If you don't want the digital, it's useful to have sometimes public record of digital assets, like someone owns the sword of whatever. But it might be useful that you don't actually have that information in a super public way, and it might be something that you can present on demand. It might be a hidden asset that you're allowed to sort of only reveal when you want to use it, for example. Also things like cross-world coordination. I imagine that if we're in various worlds as we're experiencing this, you might want to get together with your friends and say, hey, we're having a party over here, do you want to come join us? And that type of cross-world communication, if we do this based on the identity foundation that we have, can be a very easy thing to make happen across these worlds. And that would be great. It would be awesome if we didn't have silos of metaverse worlds that were very difficult to move between. And that cross-world communication can be fantastic for messaging or for other types of coordination in order to make that happen. And so there's a lot of things that can happen there in really useful ways. The output of all of the stuff that I've talked about is a trusted digital relationship. This doesn't say an online relationship because it's a trusted digital relationship even if we interact over the internet or if we interact in person, say here at a conference. The same type of relationship needs to exist in both things, and the same exact type of relationship is what you want to have in the metaverse. So it's actually not three copies of the same thing. A trusted digital relationship is the same thing you want in all of them, and that transfers between them. So that if I interact with you at a conference, we can have a trusted relationship. And if we're then interacting over the internet because we've all gone home, then we have the same nature of the digital relationship in that manner as well. That's the goal here, that we make that happen. Now, there's lots of positive outputs of this, but until we get to a trusted digital relationship, we're going to have struggles because we try to replicate all of these things in other ways. If we can get to this, we can build a lot of really, really powerful and useful things on top of that, and that's the goal of decentralized identity. And I would be a horrible open source advocate if I didn't shill a project that I'm involved in. This is in HYPERLEDGER, which is part of the Linux Foundation. I work with the ARIES project a lot, which is oriented around creating software agents, both on the enterprise sort of issuer verifier side and on the holder wallet side in order to make that happen. So we're involved in this. It's all open. We'd love for you to join us. But I understand also if you'd rather we just worked it out and helped you understand the appropriate technologies, that's cool too. We're all building pieces of this. But this is the project I'm involved in a lot, but this is the project I'm involved the most with. So there's a little bit of a shill for my favorite open source project. And thanks. I'm Telegram Sam on all the socials, so you feel free to email me, and I will be here tomorrow for the Birds of a Feather session.